All right. Kenapa dia ada kat sini? Dia punya recorder ni ada kat page pula. Hold on. 1 minute. So they recorded. Okay, let's continue with Cleanroom. So yesterday we have gone through the introduction to Cleanroom. So we have seen what does it take to be Cleanroom, what are the contamination sources, what's the ISO and the standard and classification for Cleanroom, different classes. Right, we stopped here yesterday. We have seen that human contributes to about 75%, 3/4 of the contamination sources in the space. Ventilation 15, room structure, and also equipment. And even though the equipments are not moving, in terms of its location, but there are also moving parts. There are moving parts in the equipment, and some parts are actually exposed to the environment. So this also contributes to the contaminations in the fab. So let's go through one by one in terms of the contamination description. The first one is particles. So there are many types of particles in the fab. There are also some particles can also be killer defects. Killer here means you ada a few counts of these particles and your device will be gone. It will not be working anymore. Okay, so killer defects. So it's going to cause measurable impact to circuit function or completely destroy. So that's how I mean by damaging the devices. There's certain defects. Last time when I was in lithography, there's one defect called circular defect. Dia punya bentuk dia macam duit shilling. What's duit shilling? Hold on, where's my shilling? Okay, bentuk dia macam ni, bentuk dia macam duit shilling. So this is your wafer. This is your wafer cross section. So it sits like that. Right? It sits like that. Bentuk dia macam duit shilling. Exactly like 50 cent. Cumanya dia kecil lah. The size is like 1 micron, 2 micron. So it's due to moisture during processing. So this particular defect, or we call it circular defect in the lithography process, one count, you have it, the equipment and process are shut down. Done. Right. Apa maksud shutdown? Kat sini, bila you ada satu defect tu, so the process and equipment shut down. It cannot run anymore. So nak buat apa tu? So you have to open the equipment, go through the process, troubleshoot, and run test wafers. Dalam fab kita ada test wafer. Test wafer ni wafers yang kita tak pakai untuk production. Tapi dia macam dummy wafer lah. Dummy wafers you can run through equipments, you can run through process recipes to check whether they are okay or not. So you need to do the test run. Technically we call it qualification wafers or qual wafers. Kalau you work in a fab, then you will be familiar with a qual punya keyword. Qual to means qualification process before you actually release the tool to run mass production. So you need to troubleshoot the equipment. If it's due to the equipment, if it's due to the process, then you have to troubleshoot the process, the recipe, or the parameters, fix them, and run the test wafers through the equipment and the process again. Make sure there's no more circular defects on the test wafers. Proven, no more defects, that you can release to production to run as usual. Okay. So we have different kind of particles available in the fab. Some particles can be tolerated at higher counts. Some particles are tolerated cannot be tolerated at all. So one is enough to kill the whole device. Right? We have cosmetic defects. which are visible but there is no impact to the circuit function. Dalam fab, if you if you run with a fab, how do we measure the impact to the circuit function? Do you have any idea? Macam mana kita measure? What is the parameter that you use to measure circuit function? Circuit function ni wafer tu functioning ataupun tak lah, right? So what is the parameter? Anyone knows? Any idea apa parameter kita pakai? So let me just zoom out for a while. Okay. Siapa tahu ada what is the parameter that we use to measure the circuit function? Let me write down here. Oh, it's not working here. Saya punya pen ni ada problem ke? Alrighty. So it's called yield. Okay. Circuit function ni kita measure the impact that we measure in terms of circuit function tu is named as yield. So yield percentage lah. So this is what you get by the end of the 2 months of processing. So you want to know the yield of your ICs, of your devices on the wafers. So usually dalam fab, well, we have different specification for the yield. Of course, you want to target 100% yield for every single device that you fabricate, but there's a minimum yield percentage that can be tolerated. Yang kita dah commit kat customer lah. So dalam fab kita ada yield engineering team. So kita ada yield engineer yang akan tengok kerja dia, tengok yield je. Day in and day out dia akan datang, dia akan tengok device atau teknologi yang dia in charge. So dia akan compile the report of yield punya data. So for example, if you're running, if you're assuming your fab is running FinFET of certain technology of some device structure, so you are the person in charge as a yield engineer. Then you punya day in day out work will be looking at yield of your FinFET of certain technology and device structure and make sure the yield is as high as possible. So assuming your bottom limit, or call the specification, maybe you can tolerate down to, I don't know, 99% or 98%. If your yield is 98%, it's considered okay. Well, this doesn't go across the board. It's not applicable across the board. It depends on your technology, on your devices. Let's say if you can tolerate 98% minimum, so maksudnya if you get 97%, it's no longer acceptable. Okay, so if you get 97% or let's say 96%, 96.5 yield, so it's no longer tolerable. So what do you think will happen if you are a yield engineer in a wafer fab, and then your minimum spec that you can tolerate is 98%, and then your device that you are in charge is coming out with 97.8%? What do you think will happen? Or 97% maybe. So apa yang you rasa akan jadi selepas tu? Just guess. What do you think will happen? Ni case study lah, soalan case study ya. Kalau you jadi yield engineer, then you punya yield is not enough. So it's not enough by 1%. So what's going to happen? Anyone would like to guess? Come on. Naim. Naim, do you have your mic on? You are the yield engineer now. What's going to happen to your device? Your minimum is 98%. Your products are showing 97%. So short by 1%. What do you think you will do? Mungkin soalan interview juga nanti ya. You interview for yield engineer punya post. Soalan thinking lah. What do you think will happen? Shahira Salim. What do you think will happen? Unmute yourself, please. Kalau you di yield engineer, apa yang akan jadi lepas tu? What do you think?
Hi, Doctor.
Hi, okay. So you are the yield engineer in charge. What are you going to do?
Maybe cut the cost of the
Cut
cell.
the cost? No, okay. The problem now is your yield is low. You punya target is 98% minimum. So maknanya kalau you punya products are showing 98 to 100, they are considered good. If they are below 98%, they are considered bad. So you cannot, bad means you cannot sell to your customers yang you dah commit. Dah order daripada you. Maybe Apple order from your fab, then you're committing to them 98% or more, and then you're getting 97%. What do you think you will do as a yield engineer? Agak-agak you nak buat apa, Aisyah?
I don't know.
Agak-agak lah. Apa yang you, kalau you are given the choice, you are given the authority, what would you do? You nak buat apa dengan, apa you akan cuba buat, Yos? To get the numbers back to 98% or more.
Buang defect tu.
Okay, sorry?
Defect tu kena buang dulu.
Kena what?
Removekan dulu defect.
Removekan defect, okay. Good, okay, done. So you plan to remove your defects. So let me ask your friend. Liana, you need to remove the defects. How would you do that? What's your plan to do that? Saya tanya soalan as a CEO of a wafer fab. This is how it's going to go in the fab later on. Kalau every day we're going to have a meeting or department meeting, operation meeting to review what's the problem of our production line. So now the CEO is asking you, or maybe the COO is asking you, so Liana, you are in charge. So how would you remove the defects? What's your plans? Apa yang kamu buat rasanya? If you're given a choice, what would you do? Liana? Tak ada, Liana? Anyone else? Hazika, you're the next in the line. What would you do? Unmute. Agak lah. It doesn't have to be correct though. What do you think you will do? Kita nak remove defect sekarang. So you nak kena buat apa nak remove defect ni? You are the yield engineer.
I don't have any idea.
No idea. Okay, that's fine. One more, then I'll tell the answer. Okay, Izyan. You are the next. You are sitting in the next cubicle to Hazika. What's your plans?
I don't have any idea too.
Oh, okay, all right. Okay, so say nak test you on the job description of a yield engineer. Yield engineer actually they kena monitor yield. So ni just to give you the actual perspective out there, nak relate back to the defects. So saya tak nak you belajar defect and yeah, that's it, gone. I want you to foresee what's going to happen in the actual reality, okay, in the real life. So defects semua ni will be taken care by yield engineer usually. So yield engineer dia akan monitor day in and day out what is the progress, how's the numbers like, what's the plan. So to execute the plan, the yield engineers cannot do themselves. Sebab dia punya kerja monitor yield je. Dia tak handle process. Dia tak handle equipment. So what has to happen is the yield engineer in charge has to go back to the process or the equipment under what we call yang dia suspect lah to cause such defects. Katalah we're gonna learn later on if it's due to the circular defect and the suspect is due to the lithography process from particular equipment, particular process recipe, then the yield engineer kena cari process engineer or equipment engineer or both yang run the process yang produce circular defects on the wafers. So yield engineer ni dia kena ligan lah, dia kena ligan process engineer, kena ligan equipment engineer in charge in order to get the defect removed and yield goes back to the target. Okay, itulah antara kerja yield engineer. It's not everything, but some of the main scope. Okay, they cannot do themselves. Right, get back to this. So basically you have to monitor the circuit function, the impact of circuit function in terms of yield. If the yield is not good, then you basically cannot sell the products, or maybe you tak boleh ship pun the product to your customer because they won't pay anyway, kan? Because kalau you dapat chip yang functioning, who would pay, right? Or maybe if you have a lower yield, the reliability of the chip is already compromised. So if it's supposed to run for 5 years without fail, then maybe it could run up to 2 years, then fail. So customers tak akan happy lah. So dia akan ada what they call chain reaction, akan ada domino effect after that. So kill rate, percentage of times a particular defect kills a die. So just like what I said just now, some defects can be tolerated, and some other defects cannot be tolerated because it will just kill your device instantly. Okay. So kita belajar kat situ tadi tu function yield engineer. Nanti bila you nak tengok apa ni when going for your job hunting or LI, first thing you have to look at is the JD, job description. Okay. So I taught you a little bit just now about job description. Tengok what is expected of the post. What are you expected to do? What are you expected to know? What sort of qualifications do you need to have in order to execute the job successfully, right? So it's called JD, job description. Next, other types of micro-contamination or contamination is metallic ions. Kita dah belajar hari tu, if you have the metal in your device, then they will be trap states in the band gap, in the forbidden gap. They can also alter electrical characteristic of your devices, because if you have your channel here, then you have metal sitting somewhere else. So the metal could be an alternative conductive path for the carriers to move. So they can potentially short the device and in fact kill the device as well. Right, some metal ions are mobile in nature. So it may initially be located at one benign area, but later it can migrate into a more active area and cause failure as well. So that's why kita ada discuss hari tu about the thermal cycle, right? If you remember, a few lectures back, I did mention about thermal cycles, because throughout the 2 months, 3 months of processes, the device will actually go through a series of high temperature processes in order to enable device operation through, for example, annealing process, diffusion process. We're going to see later on. So this thermal cycle, bila you have thermal component, so you can also indirectly, accidentally induce migration of your metal ions to other contaminants, to other regions of your device. So in this case, if it's migrating from benign to active area, so it may kill the device as well. So that's why monitoring the metallic contaminants in the device or in the wafer, if like, is crucial. Sodium is the worst mobile ion contaminants. So it comes from the sweat, from the skin, from the hair. So that's why kita kena gown up properly. Face mask, goggles, hood kat atas kepala tu. So you have to cover. So also present in chemicals. So semiconductor industry requires low sodium grade chemicals. You don't want to introduce sodium purposely on your wafers. Right, other types of chemical contaminants, trace of chemicals in water, in processed chemicals. So you're going to use water for your rinsing, DI water. So you're going to use lots of chemical for various processes, CMP, lithography, etching. Ada lagi banyak proses yang akan pakai chemicals. Photoresist in lithography, you will see later on, because you need to spin coat your photoresist, and then you need to absorb the incident light from the scanner in order to produce features on the silicon wafers. So it has some trace chemicals as well in the resist. Bacteria can also be there. It can be in the water, right? So it's important to keep the water flowing. The flow rate has to be correct. if you talk about running a wafer fab, usually all these gases, chemicals, water, air, compressed air, nitrogen, and whatnot, they are usually supplied from different level of the fab. We call it sub fab. If you talk about Silterra, for example, sub fab. Dekat level atas we call it fab. Level atas we call it fab to do all the operation. Dekat level bawah macam basement, so we call it sub fab. Sub fab ni is the place to store chemicals, gases, and everything. So we have piping coming in to the upper level, which is the fab level, to do the operation. So semua tu dia coming daripada bawah. So it's important to consider the flow rate, the gravity effects, the length, the diameter of your pipings and everything. And you have to get them correct. And these are all in charge by facilities department. Facility department yang akan monitor gases, water, chemicals, and whatnot in terms of their, the delivery, right? The delivery. So, okay. In fact, the electrical supply is also monitored by facilities department. So it's not only the wafer fab processing, so it's somebody else as well. So in facilities department, we need chemical engineers, mechanical engineers, electrical engineers to do all the monitoring to make sure that the fab operation is not impacted. Static charge is also another type of contamination. So you want to reduce the static, so it will potentially attract particles to the surface due to the static effect. So you don't want to attract unwanted particles to the surface. So we have ESD monitoring, electrostatic discharge. Okay, kita akan ada every now and then QA punya, I call QA punya monitoring, including the ESD punya measurement. So this is all done by QA department, quality assurance department. Okay, static charge. So it can be controlled by using anti-static materials, discharging through ground strap. So kalau you get to do your intern or work in a fab, you'll see later on major dalam wafer fab semuanya di grounded, right? It's grounded workstation lah. So you have the computer for the operators to key in details, and equipment technicians to, in fact, for engineers as well, to key in what's going on in the equipment or on the process. So those tables are actually strapped and grounded. So we do have ionizers as well to neutralize the ions in the air, even though we have the alpha and HEPA filters on the ceiling to control the incoming air quality that we discussed yesterday. Right, people is it's the main source actually. So we emit 10 to the 5, 10 to the 6, around millions of particles per minute when in motion. So just 1 minute. So just imagine how many hours you're gonna spend in the fab every day. Kalau you, okay, just to give you some perspective, kalau you kerja as a wafer fab engineer, as you are a process engineer or equipment engineer maybe, so you will be spending most of the time in the fab. So you ada cubicle juga lah dekat office for you to do all the processing, sending email, replying emails, do some documentation, presentation and stuff. But most of the time you'll be in the fab. I would say if you work 9 hours a day, perhaps 5-6 hours in the fab every day. So 1 minute is like millions of particles. So times 60 minutes times 4 hours, 5 hours. So because you are always in motion, right? You're checking this, checking that, checking wafers. So clothes, skin, flakes, hair, breath, makeup, sweat, saliva. Okay, so we have everything that we can use to contaminate the fab, right? So for this reason, we wear bunny suits in a clean room. So it's made of polyester, Gore-Tex. We have helmets or hoods, 1 or 2 pair of gloves. We have booties as well. Okay, so that's why we need to dress up. Water can also be a cause of contaminant, particles, bacteria, organic. So that's why the water quality has to be monitored, and this is done by facilities department. So kalau dalam facility department there is a post what we call engineer, water engineer. Don't be surprised. Water engineer. Kerjanya monitor water quality. incoming water maintenance, calibration, whatever, flow rate, all this contamination punya measurement. So the goal is to supply high quality water to the fab for semiconductor processing. Dia orang macam belakang tabir all the gas punya engineer, chemical engineer, water engineer, they're not on the stage. They are backstage. Right? They are doing all the work backstage. They make sure everything's okay. Then on the main stage tu kita buat all the show. The show means the semiconductor processing, lithography, etching, implant, thin film dielectric, CMP, so on and so forth. Right? So it's equally important. It's equally important. So DI water is used, bukan normal water. Kita kena pakai DI water or deionized water. So water purity is measured using a resistivity monitor. So it's usually, if you're talking about ULSI process or ultra large scale integrated circuit, so it requires 18 mega ohm, just like what we use in our NOLAB, 18 mega ohm cm of resistivity. Okay, so tap water, if you look at this in comparison, is approximately 0.0002 mega ohm. So resistivity is much lower than the ionized water. So you cannot use normal water to do fabrication. Okay, it won't work. Chemicals, another we call potential cause of contamination. So chemicals may have metallics, particles, and other chemicals, well, chemical trace if you like. So we use a lot of chemicals. We're gonna see later on in our processing. Almost every process, I think, maybe except implantation, do not have chemicals. The rest, yeah, wafer cleaning, lithography, etching, thin film dielectrics, maybe no chemicals. Metals, CMP, we also have chemicals. Yeah, most of processes use chemicals. All right, gases, right? We use lots of gases. We have silane, hydrogen, nitrogen, oxygen. So many gases in the fab, and it's also monitored by facilities department. We have gas engineer to do the monitoring, to do the control of the incoming gas quality. So we also have various suppliers as well, like Air Products, Linde, to supply the gas to the fab. Equipment can also generate particles. Okay, so we have moving parts in equipment, bearings, materials used to make the equipment determine the contamination level as well. Whether or not it's manufactured in a clean room, so deposit generated inside the chamber. So as you run the process, you will normally have the deposits or residue of the materials build up, if you like, build up in the chamber. So that's why kita perlu ada PM. Anyone knows what is PM? Equipment PM. Tahu tak, what is PM? Ever heard of this word PM? PM is preventive maintenance. Right, preventive maintenance. Right, PM is preventive maintenance. So it's usually carried out by equipment technicians, ET, equipment technicians, or EE, equipment engineers. So these are the person in charge of equipment. So we'll normally have a range of PM. So PM ni maksudnya kita macam kita service kereta lah. You have to go for service every monthly or every bi-monthly. So in this case, it depends on the equipment, but typically we have the minimum weekly PM, the most frequent weekly PM, or some also have bi-weekly PM, monthly PM, quarterly PM, semi-annual PM, annual PM, bi-annual PM. So apa beza antara each PM ni? Dia punya checklist dalam every single PM tu is different. So if you talk about weekly PM, you are monitoring all the basics yang you kena, macam cleaning of the residue on the chambers and everything is usually carried out in weekly PM. So if you go for longer PM like bi-weekly, dia akan tengok lebih detail. And if you go for monthly, more detail. Quarterly, more detail. Semi-annually, more detail. Or 6 monthly if you like. Annually, more detail. biannually more detailed. So the longer the PM is, the frequency of the PM. So the rare is the PM. So the more checklists we have to finish. So and the longer time it takes, right? So kalau weekly PM is probably in like one hour is done. If you talk about bi-weekly, it's probably double or triple. So if you go for monthly or semi-annually or yearly, it's gonna get longer. In fact, it might go up to 36 hours. From my experience in lithography last time. So when I started last time, I started as an equipment engineer. So I work on tel track system to do all the coating and deposition process, to do with the resist spinning and everything. I'll talk to you later about the process. But yeah, we have so many PMs that need to be done to make sure that we don't generate particles unnecessarily on the wafers due to the residues and quality of the equipment. Okay. So cleaning up, so we need to do clean up and wipe down. So it's also called PM. So particle monitoring is usually done by QA department. So they'll come like every month or so to monitor airborne particles in the atmosphere that you're working in the space, if you like. But in the equipment, it's done by equipment technician and equipment engineers. But in the space, it's done by QA. So they monitor many things. So few things on the basic rules in the fab, mainly due to the safety. So safety is number one in the fab. So if you're not sure of what you're doing, don't proceed. So if you don't know what to do next, don't do anything. Just stop and ask people or get somebody to help you out. Tapi usually kalau you don't know what to do means you're not well trained or you have never encountered the problem before. Okay, kalau you dah buat tapi tak tahu means something's wrong with you. Okay, you better check on yourself. So if you're not sure, don't proceed. Don't just press just to try to see what happens. It won't work. It will cause damage. Never work alone. You need to have a buddy all the time. So you're not allowed to work alone just in case if gas leaks or chemical leaks or whatever, you don't know. You need to be working with your buddy at all times. Know the rules and follow them. That's why the safety induction is super important. You have to be trained first. You have to be certified. Then only you'll be given access to enter the fab. Keep your work area clean and neat. This looks very very simple and nothing is not technical, but it's super important. Operate equipment as per spec. Specification means the manual, the procedures. Don't just do whatever you think you want to do. You have to follow the spec. So that's why we have specs in the fab. If the spec is wrong, work within the system to get it changed. So if your spec is wrong, if the procedures are not correct, update the procedures, and then you have to, once the procedures are updated, you have to follow the procedures again. No emergency exit routes. So there'll be evacuation from time to time. Kalau ada gas, for example, or something leak, or some fire, or in fact fire drill, you have to be evacuated. You have to evacuate yourself from the fab. Kalau you kerja dalam fab, then you are wearing bunny suit, right? So when you talk about evacuation, if you talk about Silterra, last time the evacuation assembly point is in the parking area, so you have to go out, evacuate from the fab in your bunny suit. So and then you'll be in the broad daylight. Hari panas kat luar, then you have to wear bunny suit until you are called back into the building. So it happens from time to time. Know where showers and eye wash stations are. I had one experience on this when we were working on preventive maintenance last time on the equipment. I was in the fab area doing the maintenance on the equipment, and our vendor was in the sub fab doing maintenance in the sub fab area on the chemical cabinets. And then what happened was accidentally at the IPA or acetone, I couldn't remember, it fell off from the fab level to the sub fab. So memang tinggi ya dia punya, the height is like 2 double story kot, dia punya difference, 2 or 3 double story house, the height between sub fab to fab. And IPA or acetone, I couldn't remember already. So it dropped from the fab level to subfab, and too bad the bottle went into his eyes. So masa dia tengah buat maintenance, masuklah mata, and dia luckily dia ada buddy waktu tu, buddy system working together with him. Then the buddy brought him to the eye wash, to the shower lah, to we call to clean the eyes. Kalau you just imagine if you're alone and then you have chemical splash or something, and then you are blinded, you cannot move, you don't know where the shower is because you cannot open your eyes at all. Then at that point you will appreciate working together with your body. So you have to know where the eye wash. Kalau nak buat maintenance dalam fab, better sebelum you start tu you dah tahu location of eye wash and everything before you start the work, so that if any incident happens, you know where to go. Okay. Know where EMO buttons are. Apa EMO button ni? Do you know what is EMO? Pernah dengar tak EMO button? Anyone? It's emergency off button. Okay. Why is it important? Emergency off apa? Emergency off ni ada dekat equipment. If you press MO, the equipment will stop working instantly. So kalau ada robotic arm tengah run, it will just stop. There's no current supply, current off, right? So there was an incident in GF last time, in Chartered Engineer last time, got Chartered Semiconductor, not Chartered Engineer, Chartered Semiconductor in Singapore, where the engineers were doing maintenance on the equipment, and then sebelum you I think they forgot to press the the interlock. Ni interlock lah, it's not EMO. Interlock, dia terlupa nak buka, enable the interlock. Then bila you enable interlock, then the robot cannot run. When the robot doesn't run, you can do your maintenance on the robots. Okay, so, but because robot they can move at high speed, X, Y, and Z, and also theta at high speed. So I think they forgot to enable the interlock, and then somebody was doing maintenance on the robot, and then somebody accidentally ran the process, and interlock tak on, tak enable. So the system was actually running, and the robot was running, and with the engineer inside or technician inside, and the robot broke his shoulder at high speed. The langgar and broke shoulder. So don't underestimate the importance of interlock button. And at that point, kalau tiba-tiba you nampak robot run and you want to stop instantly, macam nak jadi accident lah kan. So you just go to the EMO button and press. And at that point, it's okay. Kalau saja you nak lalu tu press EMO, then you're dead. Tomorrow you're going to lose your job. Okay? Incidents, okay. Okay, always wear PPE or personal protective equipment, bunny suit and everything. Wear it correctly. Do not take shortcuts. If you're not sure, ask. If you're not sure, don't proceed. Get help. Do not take shortcut. Macam ni kot, boleh kot macam ni. No, it's not acceptable in the fab. Alright, so last time when I was working during my time, the wafer in each pot, each wafer cost like 1,000 USD for 8-inch completed wafers. So one piece of 8-inch costs like 4,000 RM. So just imagine if you have a pot of 25 wafers, satu pot yang you bawa tu is actually worth 100,000 RM. Okay, so anything happens, you break ke jatuh ke whatever, on purpose, you're dead. Okay, follow all the PM safety procedures, lockout, interlock, MOs and everything. Know the potential hazards. So read MFDS. So what is MFDS? Did you do your Sopra last time? Bila you buat FYP, you buat Sopra kan? If you buat in lab. Still remember your Sopra? Standard operating procedure and risk assessment. Okay. What is SDS? Safety, before you do your Sopra, safety data sheet. You have to know what are you working with, right? So if you're working with HF or photoresist or ethanol or some other chemicals, NaOH or KOH, whatever, you have to know all the safety data sheet. You have to know the details of the chemicals. What is the potential hazard? What can it be mixed with? What it cannot be mixed with? So you have to know everything about the chemical before you can work on the chemicals. So these are among the safety or basic rules before you do your work in the fab. Yeah, that's it. Right? So this may seem trivial at this point, tapi bila you dah kerja dalam, you dah pergi ke internship later on, or you get a job in a fab or in other factories of whatever nature, there will always be safety rules for you to work with, for you to look up to, right? So you have to really be careful. You have to really understand the safety concerns of your space, of your industry. Okay, so they are all do's and don'ts, and you are not also allowed to play in the fab macam you nak melawak ke apa kan. So it can be dangerous because you are in your bunny suit, and yeah, it may be hazardous as well to some extent. Okay, so done for clean room. Any questions for me before we end for today? Ada soalan ya? Anything on clean? Any questions? All good? Ada. Okay. Faika, what is the solution for the wafer earlier? Sorry, solution of the wafer earlier. Oh, the yield problem, is it? Oh, okay. The yield problem. Okay. Well, normally what will happen is yield dia akan ada frequent meeting dengan every department. So every department in the fab is usually assigned by the process name. So if you talk about it's usually lithography department, etching department, thin film department, implantation, diffusion, oxidation, stuff like that. So yield engineers will normally have frequent meetings. So the meeting is a platform to highlight what is the ongoing problem, including the yield problem on certain technologies, certain devices. So that's where the yield engineer chases process engineers or equipment engineers in charge of that particular process or equipment to look into the problem within certain time frame. So then yield engineer, they can follow closely like what's the status of your findings on circular defect problem in your tail track equipment, maybe something like that. So in fact, the yield engineer can also go into the fab. Yield engineer ni dia jarang, bukan dia jarang masuk fab, dia selalu masuk fab. But then dia punya kerja tu dia tak ada satu specific process yang dia in charge, because he or she is looking at the yield overall. So bila you tengok dekat yield ni, the impact of the circuit function at the very end of the processing. So the problems may be coming from the very first process until the very last process. So dia kena oversee the whole, the whole process and where the problems could be. So it depends on where is the root cause of the problem. So if the root cause comes from the oxidation process, step number X, then the yield engineer has to follow up with the process engineer of oxidation, step number X, in equipment Y, to be able to get the problem solved. So you can even go with the process engineer, equipment engineer into the fab and looking at what they are doing to actually solve the problem, to, I don't know, change parts or change process parameters and rerun and prove that the defects are gone. Okay, but you don't really press buttons and change here and there to get problem solved, but you work with somebody else. So in this case, process engineers or equipment engineers. So banyak department, I'll show you later on how does the whole system works. But generally, if you work in a wafer fab for IC fabrication, there'll be a group called fab operation and fab support. So fab operation is mainly on the processing, like lithography, etching, implant, thin film, CMP, and yeah, oxidation, diffusion. So these processes are categorized as fab operation group, and the other group is called fab support, where you have FA, failure analysis, reliability, customer engineering, yield engineering, and other departments, other other roles that are required to support the operation. So kalau you work in the operation, then you will be process engineers or equipment engineers. If you're working in fab support, then you'll be a CE like customer engineer or yield engineer or what else? FA engineer, reliability engineer. So nanti you try browse on the, for example, Silterra or Infineon website. Look at the organization structure, maybe all the vacancies that they offer. Then from there you will see how how the role comes in terms of fab support